Thank you, Vast, for giving me opportunity, and a very good afternoon, all of you. I thank to my co-author, Dr. Purnima Padida and Dr. Wafa Saleh. Actually, today I am going to discuss about a very critical problem of road safety in traffic engineering, where the driver follow each others. And the structure of my presentation is like this, where I will cover introductions, objective, methodology, results and discussion, and followed by conclusions. Now question is, why to study the headway? Because it has got the several applications to solve the problems of traffic and transportation engineering, solve the problem related with safety, solve the highway capacity problems, and level of service of the highways. I would like to define the headway. Headway, you can say time headway or distance headway. Time headway is the difference between the time when the front of the vehicles arrive at a point on the highway and the time of the front of the next vehicle arrive at the same point, and then the difference we call as a time headway. Basically, time headways has got 2-second safety rules. What we call as a 2-second safety rule is based on the reaction time of the driver, and the reaction time is affected by the number of parameters that could be drivers and speed, and then reading, texting, and maybe drunken driving. According to Lam et al., he described that alertness, complexity like fatigue, distraction while talking with passengers or using the mobile phone, and a sudden obstacle coming along the way that may affect the reaction times. And sometimes driver fall asleep while the driving. That's another problem due to the fatigue. Apart from that, there are complexity of relationship between reaction time and these all factors, and that makes the decision of the driver complex. These are the few situations I would like to say where there are no lane discipline. You can see the many different types of the vehicles like cars and even hand carts are being driven on the same roadways, and that create. And if you see here this case, this is the national highway of India, and where we can see such type of hand driven cart are being drawn. And there are relationship between headways, traffic flows, and as we have shorter headways, we have more number of flows. Apart from that, we have application of headways in automatic driving field, and that has created attentions like DRAPA Grand Challenge, where we have the in robotic arms, and then we have intelligence on the car itself, and with help of proper algorithm for overtaking and having the vehicle detections, vision-based vehicle detection, safe overtaking. It's possible that a time will come then when a dog can run the vehicles to your house. So it's happening already. Some types of the experiment is going on. Apart from that, we have headway distributions used for the determines the opportunity for merging at the crossing, at intersection, on the ramp, and then we find out the capacity, how much saturation flow is on the roads, and we use in the micro simulation process and simulate the different traffics. There are several research done, like Brackstone found that driver follow closer behind the trucks rather than car. He quantified the magnitude of variations of headways. Parker's found that there is no difference between car follows car or car follows trucks at the speed of 60 to 70 km, whereas Poston found that the frequency of headways less than half second varies by vehicle types. It means vehicle has some effect. Some could not present any differences. And Sayre analyzed the differential behavior between car and trucks, and they found that truck, when they found at the back there is truck, then they feel relaxed, because it gives sort of predictable vehicles in the back. So there are effect of size of the lead vehicles. Therefore, many research has been done, but still in the mixed traffic condition like what I saw in India, the research on the following behavior is not being studied, and it has some impact on our highway capacity, because we are not able to define how much capacity we have, because in 3 lanes almost we will see the 6 parallel vehicles, 7 parallel vehicles. That's the problem. So therefore this objective of a study has been taken with evaluation of time headway behavior, and I have taken a case study in northeast part, which is the very crucial from the strategic point of view, because it contains so many disputed borders like Bangladesh, Myanmar, China, Bhutan, where we still need to go take visa. And this is the study area, and this is the roads I have selected, and this is the different site conditions, and this is the site condition in another cities that's called Shillong. It's on hill, and one city was taken in the plain, and this was taken on the hill. And this is the study area, and then we use the video camera for data collection. And first we mark the stretch 10 meters, so that we can measure the speed and how much flow between that, and how much the gap between front to end. So this was the method used for distractions of the extraction of the data. And then we found out the traffic composition. If you could see here, it's 43% cycle rickshaw and 22% cycle rickshaw. This is the very unique result we compare from Delhi, where 56% cars, and we could see there 26% bike and 17% auto. And similarly in this case we could see the 22% two-wheelers. So some of the city in India, they are heavily dominated by non-motorized traffic like cycle rickshaw and bicycles, apart from two-wheelers. And then we compare the congested condition and free flow condition, where we found that if you see this percentage of truck was 2% in the congested condition, when the same road we carried out the study apart from the city on the same extended road, then we found that there was increase in the percentage of trucks, and similarly percentage of sport utility vehicles increased from 10% to 13%. Because the sport utility vehicles is not used for the sport purposes, but it's being used for the commuting purposes. It's used for the as a passenger carrier. That's the unique thing in this study area. Similarly, we carried out a study for the Shillong city, where we found the different results. Here we could say that around 66% were the car. That's a typical case study of the hill area, where the non-motorized mode is exclusively nil. Because of the hilly terrains, people are not interested to take the bicycle or cycle rickshaw. Then we find out the effect of leading vehicles on headways, and this is the plots where on every lead vehicles we plotted what are the following vehicles are coming. And as I said in the previous one, that 2 seconds is the critical safety rules. If we are going below the 2 seconds, it means we are crossing the safety, and there are chances that we are going to get have the accident. And you could see here is a 0.5 seconds, 1.3 seconds. So these are the cases. 1.2 seconds has got this critical headways. Similarly, in this case, 1.5 seconds is for tempo, and 0.7 seconds for hand cart. So if such type of headways are between the vehicles, then certainly the chances of accidents are more. And these are the different traffic in the free flow conditions. And similar analysis were carried out on different roads, and again we found that vehicles like trucks and light commercial vehicles, they are following very near to the two-wheelers, and that's the main reason where the two-wheelers are being reported as accidents. Large number of accidents are occurring for the two-wheel vehicles. So the main reason we could find out from here that the headway between vehicles, two-wheelers and remaining vehicles are very short. Similarly, we can see from here this for the cyclist, the headway between cyclist and truck it was very low, and that was the case where certainly it's going to have the accident. Similar analysis we carried out for autos and the sport utility vehicles, where we could see that vehicles like trucks has again the same case, means chances of accident with trucks and cars are more. So this shows the effect, and then we carried out the similar analysis on the hill. But on the hill we could see that the 2 seconds rule was not valid. Still they are maintaining the larger gap between the vehicles. So I am coming on the some aspect like truck maintains the higher following headways. If bus is ahead, then big cars maintains larger gaps, and when car is leading, then all different vehicles were following 8 to 9 seconds intervals. Apart from that, we carried out the analysis from within the cities and outside the cities, tried to find out, and we found out that within the cities, the for cars the gap was larger as compared to the outside city. That was the interesting things we found out, because outside the city the speed of the cars increase, and then the gaps between that, especially for the cars, even they can manage the smaller gaps. And this is the effect of flow on the driver, where we could see that for congested and for free flow, in case of free flow conditions, the headway increased by 50%. And then we plotted the speed versus headways, and then we could find out the variation of headways for different types of the vehicle. But this result is not conforming the earlier literature for parkers, where it says that at 60 to 70 kilometer speed there is no changes, but we found different results. Similarly, we plotted the headway and speed for different vehicles, and then we could find out that some of the results like Poston managed that frequency of headway varies less than 1 second vehicle, but differs in large number. Especially in mixed traffic condition, we have more number of vehicles. That is the special things. And then I find out the maximum and minimum speed of the vehicles in Silchar and Shillong, and we could see that in Shillong the maximum speed is coming higher as compared to the Silchar, because this Silchar has got different traffic characteristic, and Silchar is in plain. And if we can find out from the headway points of view, similarly we find out that headway has got higher value as compared to the plane. This is the final result I would like to conclude. Here we could see that minimum following headways for plane is 1 second, whereas in case of hills it's 2.6 seconds. 1 second means certainly the chances of accidents in this region are more. That's a clear-cut scene. Means we have to train the drivers, we have to take the traffic control measures so that they can maintain the discipline, and they can we could avoid the accidents. And similarly, if we could see the speed, following speed in the plane, it was 6.73 kilometer per hour for a hand cart, whereas in case of hills it was 18.78 kilometer minimum following speed. It means it shows that the speed in the Silchar city is very less. We have to see this as a problems, because it's going to take a lot of times in congestion and all, and probably we have to sort out some we have to take some policy decision how to prioritize the lane and how to make the better traffic sense. So I will just coming at the last. So finally, headway characteristics are of great importance for planning, analyzing, designing and operating the roadway system, and these are requirement for better modeling to understand the real world driving behavior. The driving following condition, a large number of driver adopts headway which are less than safe headway, that we need to train them. And the concentration of short headway in a way that many drivers choose less than a safe headway is serious for accidents. And especially in this study, we could say that bicycle in the lead vehicles follow such vehicles such as auto, cycle, tempo are the crossing the time headway limit. It means bicycle is very prone to safety. Thank you.